A software engineering overview. Let us first understand the software engineering standpoint. The term is made of the two words software and engineering. Software is more than just a program code. A program is an executable code which serves some computational purpose, and software is considered as a collection of executable programming code, associated libraries, and documentation. Software, when made up for a specific requirement, is called as a software product. Now, in engineering, on the other hand, is all about developing product using well-defined scientific principle and methods. Software is a engineering branch associated with the development of software product using the well-defined scientific principle, method, and procedure. The outcome of software engineering is an efficient and reliable software product definition. Uh, IIE defines software engineering as the application of a systematic, disciplined, quantified approach of the development, operation, and maintenance of software. That is the application of engineering to software. The study of approaches as in above statement. Fritz Bauer, a German computer scientist, defines software engineering as a software establishment and use the sound engineering principle in order to obtain economically software that is reliable at work efficiently on real machine. Software evolution is the process of developing a software product using software engineering principle and method is referred to as a software evolution. This includes the initial development of the software and its maintenance and update till desired software product is developed which satisfies the expected requirement. Software evolution is start with the requirement gathering process, after which developer create a prototype of the intended software, and so it is the user to get their feedback at the early stage of software product development. The user suggests changes on which several consecutive update and maintenance keep on changing to this process changes the original software till the desired software is accomplished. Even after the user has a desired software in hand, the advancing technology and the changing requirement force the software product to charge accordingly. Recreating software from scratch to the go on the with the requirement is not feasible. The only feasible and economically solution is to update existing software so that it matches the latest requirement. Software evolution law, Lehman has given that software evolution. He divided the software into three different categories: just type, static types. This is the software which work strictly according to defined specific, and solution. The solution and the method to achieve it, both the immediately understood before coding. The yes type software is the least subjected to change, hence this is the simplest of all. For example, calculator program for mathematical reputation. P types, practical types. This is the software with a collection of the procedure. This is defined by the exactly what procedure can do. In this software, the specification can be described but solution is not obvious instantly. For example, gaming software. E type, embedded type. This software work closely as a requirement of real world environment. This software has a high degree of evolution as there are various changes in law, taxes, etc. in real world situation. For example, online trading software. E-type software evolution. Lehman has given 8 law for the E-type software evolution. Continuing changes, and E-type software system must continue to adapt to the real world changes, else it become progressively less useful, increasing complexity. As an E-type software system evolves, its complexity tend to increase unless work is done to maintain the reduced conservation of familiarity. The familiarity with the softwares are the knowledge about how it was developed, why was it's developed in that particular manner, etc. must be retained at any cost. No implement and charges in the system. Continuing growth in order to E-type system intend to resolve some business problem, its size be implementing the changes grow accordingly to lifestyle changes changes of the business. Reducing quality and E-type software system decline the quality unless rigorously maintained and adapted to the changing operational environment. Feedback system and E-type software system constitute multiple loop multi-type feedback system and must be treated as such as successfully modified or improved self-regulation. E-type system evolution process and self-regulating with the distribution of product and process measure close to normal. Organization stability, the average effective global rate is evolving. E-type system is invariant over the lifetime of the product. Software paradigm refer to the method and step which are the taken while designing the software. There are the method proposed and are in the work today, but we need to see where the software engineering these paradigm stand. These can be combined into various categories, so each of them is contained in one another. Software evolution programming paradigm is subset of the software design paradigm, which is further subset of the software development paradigm. Development paradigm. This paradigm is known as a software engineering paradigm, where all the engineering concepts pertaining the development of the software are applied. It includes various researchers and recruitment gathering which help the software product to build. It consists of the requirement gathering, software design, programming, software design paradigm. This paradigm is part of the software development and include design, maintenance, programming and programming paradigm. This paradigm is related closely to the programming aspect of the software development. This include coding, testing, integration. Need of the software engineering. The need of the software engineering arises because of the higher rate of the changes in user requirement and environment on which software is working. Large software, it is easier to build wall than the house of or building. Likewise, as the size of the software become larger, in large engineering has to step to give it in a scientific process. Scalability, if software process were not based on the scientific and engineering concept, it would be easier to recreate new software than the scale and existing one. Cost, as hardware industry has shown its skill and huge manufacturing has lowered down its price and computer and electronic hardware, but the cost of software remain high if proper process is not adopted. Dynamic nature, the always growing and adopting nature of software hugely depend upon the environment in which user works. If the nature of software is always changing, new enhancement need to be done in the existing one. This is where software engineering play a good role. Quality management, better process of software development product provide better and quality software product. Characteristic of the good software, a software product can be judged by what it offer and how well it can be used. This software must satisfy on the following ground: operational, transactional, maintenance. Well engineering and crafted software is expected to have the following characteristic: operational. This tells us how well software work in operation. It can be measured on budget, usability, efficiency, correctness, functionality, dependability, security, safety, and transactional. This aspect is important when the software is moved from the one platform to the another. Portability, interoperability, reusability, adaptability, maintenance. This aspect brief about how well a software has the capabilities to maintain itself in the ever-changing environment. Modernity, maintainability, flexibility, scalability, and in short, software engineering is a branch of computer science which uses well-defined engineering concept required to produce efficient, durable, scalable, and budget and on-time software products.